nabbing some concepts, we are able to calculate the given quantities. y2 square minus y1 square, v1 square minus v2 square. Here on substitution, this is 197.2 meter per second square. So just by comparison method, I've been able to get the required results. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Hope you have gone through the previous session of problems on oscillations and you have come prepared for today's session. If you have gone through the sessions, understanding and solving today's problems becomes very, very easy. The first one, students, the problem says the equation of a particle executing simple harmonic motion is given by y equals 5 sine 20 pi t. Now the displacement equation is given as y equals 5 sine 20 pi t, where y is in centimeter and t is in seconds. Gamanse y is in centimeter and t is in seconds. I have to calculate the maximum speed and the maximum acceleration of the particle. Now, writing down the given equation, y equals a sine, it is 20 pi t. So the given equation is y equals a sine 20 pi t. Compare it with the standard equation. So here a is mentioned to be 5 sine 20 pi t. So comparing with the standard equation, a sine omega t, as we did yesterday, comparison method. So on comparison, a is 5 centimeter. Very clearly he says y is in centimeter. So a is 5 centimeter, or which is 5 into 10 power minus 2 meter. B, omega on comparison is 20 pi. So I have just compared. From those comparison, I have got the value of A, I have got the value of omega. Now, Vmax, maximum velocity, as we did in yesterday's class, recall the expression This is A omega 5 into 10 power minus 2. Omega is 20 pi. On substitution, this is 3.14 meter per second. You are expected to substitute and simplify. Now, maximum acceleration, A omega square 5 into 10 power minus 2, 20 pi whole square. Here on substitution, this is 197.2 meter per second square. See, just using the method of comparison, I have found out Vmax and Amax. The next one, students. Now, the equation of simple harmonic motion of a particle is represented by y is 0.05 sine pi t divided by 2, where y is in meter and t is in seconds. Find displacement t as 0.05 seconds, amplitude, frequency, maximum velocity, and maximum acceleration. Again, exactly the same as we have done before. Now the given equation is y equals 0.05 sine. This is pi t by 2. Now again, what do? I will compare this with the standard equation. Y equals a sine. Now this is omega t. Omega is 2 pi f into t. Instead of omega, I have written 2 pi f into t. Again on comparison, amplitude 0.05 meter. Directly, I have arrived at the amplitude. Now frequency. So if I compare the frequency, 2 pi f is pi by 2. Pi and pi gets cancelled. So frequency is 1 by 4 hertz. Now as usual, as we have done for maximum velocity and acceleration, Vmax is A omega. But omega I have not calculated separately, but I know frequency. So this is A into 2 pi f, 0.05 into 2 pi into 1 by 4, which turns out to be 7.9 into 10 power minus 2 meter per second. Maximum acceleration again A omega square, again A into omega A. This is how I can write it as. So on simplification, that turns out to be 12.4 into 10 power minus 2 meter per second square. See again, just by using some concepts, nabbing some concepts, we are able to calculate the given quantities. Next one. This is an interesting problem. The velocities of a particle executing simple harmonic motion are V1 and V2, corresponding to the displacement y1 and y2 respectively. Show that the period of simple harmonic motion has to be calculated. V1 is the velocity when the displacement is y1. V2 is the velocity when the displacement is y2. I have to calculate the period of oscillations. Now, we know velocity is omega root of a square minus y square. So very clearly in our theory we have studied velocity of a particle executing simple harmonic motion is V equals omega root a square minus y square. Or from this, V square is omega square a square minus y square. Squaring both sides, V square is omega square a square minus y square. Similarly, V1 square is omega square a square minus y1 square, because the amplitude values always remains the same. V2 square is a square minus y2 square. Now, how do I simplify? Therefore, V1 square minus V2 square will be y2 square minus y1 square into what is common here? Omega square. What is that I am aiming at? I am aiming to get the time period of oscillations. So, again taking square roots on both sides here, V1 square minus V2 square. So this is 2 pi f. Again the root here, root of y2 square minus y1 square. Anywhere can I introduce time period? Yes. So root v1 square minus v2 square is 2 pi t root of y2 square minus y1 square. What is that I have to evaluate? T. So T is 2 pi root y2 square minus y1 square, v1 square minus v2 square. So this is the expression for the time period of the particle executing simple harmonic motion. The next one, students, actually an assignment which is based from the previous problem. The velocity of a particle executing simple harmonic motion are 12.56 meter per second, 9.42 meter per second at displacements 3 centimeters at 4 centimeters. Find the amplitude and frequency. So now, velocity v1 is 12.56 meter per second when the displacement y1 is 3 into 10 power minus 2 meter, and 9.42 meter per second, displacement is 4 into meter. Again, we have v1 is omega 1 root 1 square divided by v2 omega 2 root of a minus y2 whole square. Simplify this, you get a quadratic equation where amplitude is 5 into 10 power minus 2 meter. Substituting for frequency, we get this as 50 hertz. So just by comparison method, I've been able to get the required results. My next session, I will be starting problems on waves. Come prepared for that session. Until then, have a nice time. Thank you.